Okay, so I'll try my best to keep this one really short because there's not a lot of new stuff today for you to grab, but this one is really important. So I'm going to jump into sort of thinking about some sort of weird infinite cases here with these series. So when I talk about infinity, that means we are doing an infinite number. We are doing as many as possible, and we're never stopping. Infinity is this concept. It's not really a number, but it's kind of like a number because you can kind of use it like a number sometimes, but it's weird. Anyway, basically what it means is you can keep going forever with numbers. And so, for instance, with this one, you can kind of keep going forever putting in new numbers for n. And so you start with 1, and then you put 2 in, and then 3 in, and then 4 in, and then you go all the way forever. Obviously, you can't actually do that. And because this is an arithmetic sequence that we have inside the summand, like you're going to start with 2, and then you're going to add 5, you're going to add 8, you're going to add 11, and we can pretty quickly see, like, oh, this thing is going to go for a really long time. It's going to keep increasing like forever, and it's never going to stop, and it's always going to go bigger and bigger and bigger. And so this thing goes to some infinite number. We don't know what that, like, we don't know how big it goes because it just keeps going. Same idea with this one. This one starts at 5, and then we add -7, so then it would be -2, and then -9, and then -16, and you would just keep going. That's what that dot 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 means. There's always something in like left over. So you keep going, and eventually you get to a really, really tiny number. And so eventually it's like going to go down to like a negative infinity. So this one goes to a negative infinity. Let's look at some geometric ones. So here, similar idea. I'm going to start with 3. Each step we're multiplying by 2, so I get 6, and then 12, and then 24. And so all of a sudden already, like if you just start adding those numbers up, you get a really big number. So if you keep going, you're going to keep going and going and going. It keeps getting bigger and bigger and bigger. So this one goes to some positive infinity number. The last one is the one that's like really weird. So first number is 16. Next number would be 8. You can check my work here. Then it would be 4. Then it'd be 2, and then it'd be 1, and then it'd be a half. So then we're going to explore this a little bit because it seems like it should keep going on, and it does. And it sure seems like it should keep going forever, but something weird happens here. Okay, so I'm gonna analyze this thing a little bit more. So here we go. The first one, when you just add up the first term, you get 16. When you add up the first 2 terms, you get 16 plus 8, which is 24. The next one, you get 16 plus 8 plus 4, which is 28. The next one, you get 16 plus 8 plus 4 plus 2, which is 30. I'm going to make my pen a little bit smaller for the next one. So then I get 16 plus 8 plus 4 plus 2 plus 1, which is 31. Okay. So still increasing, everything's going fine. Keep going. 16 plus 8 plus 4 plus 2 plus 1 plus 1/2. Okay, so now I get 31.5. Okay, and then I'm going to keep going. So then I get, okay, there's my face. Okay, so then you keep going, and it's like 16 plus 8 plus 4 plus 2 plus 1 plus 1/2 plus, oh no, 1/4. And now I get 31.75. This is starting to feel a little bit like Zeno's paradox, where I'm walking halfway of what's left every time. And now I'm like, am I ever even going to get to 32? So let's do one more. Uh, 31.875. Still not to 32. Am I ever going to get to 32? That's the point of this lesson. Do you see how this one sure looks like it is going to go to infinity, but all of a sudden as you start trying it, even in step 8, you can see that we're never going to get to 32? Not quite, at least. Here's the deal. This series is a convergent series, and the reason that it's a convergent series is when you start adding the terms up, you end up at a number, and it doesn't go towards infinity. So this is convergent because this series converges or goes to a value. We saw that this one approaches 32. As you add more and more terms, you get closer and closer to 32, but you never quite get there. We get to the point where our calculator just rounds it to 32 eventually, but it's still not quite there. There's still a little tiny bit of space in between there. Okay. There is a test to see if you have a convergent or a divergent series, and the test to see is your common ratio R between -1 and 1? If it's between -1 and 1, then you have a convergent series. So let's check. Each time you're going to multiply by R, is this a convergent series? Well, okay, 24 times R has to give you 18. So divide by 24. Use your calculator. There's no shame in that. I'm just going to pull my phone out and see what that is. 18 divided by 24 is 0.75. Your ratio is 0.75, or you could write 3/4. Does this make that inequality true? Yeah, 3/4 is between -1 and 1. So this series converges. I'm going to tell you what it converges to later, but it does converge. It goes to a value. Eventually you get an answer out when you start evaluating that infinite series. This one is a multiplying by 3 rule, and so since 3 is not between these numbers, this is a divergent series. So we say this series diverges because it goes to infinity eventually. Okay, if you have a convergent series, then that series, the geometric convergent series, converges to this formula. Okay, so this means that R has to be between -1 and 1. Okay, if it's between -1 and 1, then you can use this formula. This is the first term. Make sure that you put this in parentheses. Okay. Just a couple practice problems. We're assessing to see if we have a convergent series or not, and then we're going to see if we can find what it converges to. So in this one, R is 100, which is definitely not between -1 and 1. So this is a divergent series. R is between 2/3, so that's between -1 and 1. So this one converges. So S infinity is 74 divided by 1 minus 2/3. Okay, which is 74 divided by 1/3. Now I'm going to get a little fancy here just because I don't have a calculator right here. You could just put this in your calculator. That's totally fine. I'll pull my phone out in a second. But this is the same as 74 times 3. If you don't believe me, you can just put it in and check. But 74 times 3 is 222. So my answer is 222. This series converges to 222. And I know that because the ratio is between -1 and 1. Last one to talk about here is just this one. Oh, look, this is an arithmetic series. all arithmetic series, when you go to infinity, diverge. So this series diverges because it is arithmetic, and you can check because number one, there's no exponent. But number two, if you start putting in the values for that n, you are going to see that there's an adding rule there. That is it. Okay, so summary. Only geometric series can converge. Only geometric series that have ratios that are between -1 and 1 can converge. And only convergent geometric series converge to this value. Okay, so you can use those pieces of information to find the value of that infinite geometric convergent series, and you'll have a little practice with this, and then we're done. That's it.